Good morning, Honors Algebra 2. It's Thursday, April 9th. We have a 3-day weekend coming up. Tomorrow is Good Friday, and so this assignment will not be due until Monday. So today we're going to talk about periodicity and symmetry. You'll notice on this top graph that I have on my iPad, we have an upside down V. And this is going to be a periodic graph or a periodic function. It's going to have a repeating pattern or a repeating cycle. And the period is defined to be the horizontal distance of a single pattern. So here is a length of 2. And we're going to repeat this pattern with a period of 2. It's horizontal length of one of the patterns is 2. So let's continue the pattern by going up here and down here, and we're going to go up and down. Let's notice here at the top that we want to graph this periodic function from -5 to +5 for my x values. And so I've gone to the right 1, 2, 3. So I'm going to have to go 4 and 5. Whoa, that was a little off, sorry. And then let's go over to the left of the y-axis and repeat this and see if we can have our period, our interval go to -5. So I'm at -1, -2, -3, -4, -5. And so that is my periodic graph. It has a period of 2. The horizontal length of one of my repeating cycles is 2 units. Okay, now notice that this top graph is symmetric about the y-axis. So if I made a line of symmetry in blue, it would go right down the middle there. The y-axis splits this up into two a reflection on the left and the right side. And so we call this function an even function. An even function is symmetric about the y-axis. The y-axis is a line of symmetry. Now let's look at this bottom function. This one has an interval, a period. Let's see what it has here. This has a period of 1, 2, 3, 4 units. So its period, I'm going to keep this in green, its period is equal to 4. Now we call this function an odd function. Notice that it is not symmetric about the y-axis, but it is symmetric about the origin. Now what do I mean by that? Well, let me go ahead first and erase that little green line so we don't get confused. Well, let's go ahead and look at this point. This point is the point 1, 1. Now, if it were symmetric about the y-axis, we would have a point over here at 1, -1. But it's not at 1, -1. It's then reflected across the x-axis, and it's down here at -1, -1. And so it really reflects across the y-axis and then across the x-axis. And so notice when my x value becomes -1, my y value also becomes negative. That's going to be important in just a minute. And let me go ahead and erase this dot. And let's go over and look at this point over here. Now this is the point 3, -1. Well, let's see, if it were symmetric on the across the y-axis, we'd go over to 1, 2, -3, -1. But we don't do that. We then reflect across the x-axis, and we're up here at -3, +1. And so note what happened here with an odd function. When the x becomes negative, the y is also negated. All right, so let me go ahead and erase that. Those are odd functions. Now let's go down to the next page and let me draw something here. We're going to draw an even function. We're going to draw an even function, and the function is going to look like this. We're going to start at the origin. We're going to go up, stay across, and go back down. Now let's make this an even function, To do that, it's going to be symmetric across the y-axis. So let me go ahead and first connect these points. It's kind of hard on this glass surface of my iPad. Now I'm simply going to reflect it across the y-axis. So here I go. That is an even function. Now let's go down below here and make it an odd function. Let's make it an odd function. So here we go. I have the same original graph, and I want to create an odd function. Well, it's going to be symmetric about the origin. So I have the point here, up here, of 1, 1. Now, if I were to make it an even function, I would have, let me make it blue, I would have a dot right here. But I'm not going to do that. It's an odd function, so I'm also going to reflect it across the x-axis. And I have a point down there. Now let's go back and look at the second point over here on the right side. We've got the point 2, 1. Now, if I were to make it an even function, I would come over here to negative 2, 1, but it is an odd, and so I'm going to reflect it across the x-axis as well. So then my last point on the right side is the point 3, 0. Well, I'm going to reflect that over here to negative 3, 0, and I can't really go anywhere with that because I can't reflect something across the x-axis that's on the x-axis. So it's just going to stay there. And I have my graph of an odd function now. This is symmetric about the origin, while the even function is symmetric about the y-axis. Now, I'm going to try, hopefully, let me go to my photos here, and I have a photo of this page, and from our book, it's the oral exercises, and I want to, oh good, it worked. I want to tell the period, and I want to tell whether it's even, odd, or neither. So let's look at number 1. Number 1, let's first talk about the period of this function. Now, we have to be careful here. We're looking for a complete cycle, the length of a complete cycle. So we could do 2 things. I'm just going to go from peak to peak. From peak to peak here, I'm going to, and it's like an upside down V, I'm going to find the horizontal length of this cycle or this period. And it goes from 1 to 5. So the period is equal to 4 units. Now, is it even, odd, or neither? Well, let's look. We have the point 1, 1, and so if it were even, we'd have the point over here, negative 1, 1, but then it's reflected across the x-axis as well. And so this looks like an odd function, and in fact, if you keep plotting your points and looking to see, does it reflect across the y and then across the x? Yes, it does, and so we call this an odd function. Now, let's go ahead and look at the next one. Well, let's skip down to number 3 first. All right, number 3, let's look at the period here. So right from here to here is my horizontal distance of 1 cycle. So this one has a period of 2. Now, is it even or odd? Well, look at it. It is perfectly symmetric on either side of the y-axis. So this is an even function. Let's go back to number 2. Number 2, let's look at the length of 1 cycle. I'm going to start with this here to here is the horizontal length of one of my cycles, or one of my repeating pattern here, and it has 1 to a period of 3. Now, it's definitely not even. We don't have symmetry across the y-axis. Let's go ahead and pick the point 1, 1 right here and see if we go across to the point 1, 1 over here. I'm sorry, 1, negative 1. This would be 1, negative 1. That would be, it was even. If it were odd, we would be plotting the point, I'm so sorry, that's negative 1, positive 1. Eek, hold on, let me fix that. Tired teacher. Okay, let's fix that one more time. I'm so sorry. So let's go back here. This is the point up here, negative 1, positive 1. All right, now, if it were even. If it were odd, it would be negative 1 down here, but it's not. It's just stuck right here at negative 1, 0. So this is not odd and it's not even. And so we just put neither. So now I'm going to switch to our whiteboard and show you how we can see if a function is even or odd algebraically. So let me get out of my stop sharing here, and here I am. Okay, so now let's pull up our board here, and let me just stand up, and let's look at what I have here. Let me pull the board a little bit closer. Here we go. Now, here we have the definition algebraically of an even function. An even function, let's look at the picture first, okay, and this will help us. An even function is symmetric about the y-axis. So that means if I have an x of 1 and a y of positive 1 also, when I make my x negative, my y will stay the same. It'll stay positive. Now with an even function, if I change my x to a negative number, okay, if I plug in a negative value for x and I'm graphing the negative x, my y will be the same as it was over here with the original f of x. So here, the f of 1 is the same as the f of negative 1 because the f of 1 is your y value, the f of 1 is 1, and the f of negative 1 is also positive 1. So basically, when you change your x to a negative, when you negate your x, your y will stay exactly the same, okay? And this is the example. The f of positive 1, or the y value when x is positive 1, is the same y value when your x is negative. Now, let's look at an odd function. Here, remember, when you have a 1, 1 for your x, we're going to flip it over the y-axis and over the x-axis, and when x is negative, y becomes negative, okay? So let's look over here. When I plug in the negative 1, when I have an x value, of negative 1, my y value is going to be the opposite of what it was originally when x was 1. So the f of negative 1, or the y value when x is negative 1, okay, is going to be the opposite of the y value when x was positive 1. I know that seems a little bit confusing, but let's just go over that one more time. When I take my x and I change it to a negative x, my y value will change to the opposite of what it was originally. So the f of negative 1, which is your y of negative 1, is going to be the opposite of what your y value was when x was positive 1. Okay, now let's go ahead and look over here and decide whether these functions are even, odd, or neither. Excuse me. So I have the f of x, here's my function, is x squared over x to the 4th plus 1. Now what I'm going to do is I'm now going to find the f of negative 1, of negative x. I'm going to find the f of negative x. So I'm going to take this normal function and change my x to negative x and see what I get for an answer. So take your x and make it negative. Take your x and make it negative. And I get x squared, and down here I get x to the 4th plus 1. So sorry, I don't have any water. Okay, so look, my f of x and my f of negative x are the same thing. So my f of x and my f of negative x are equal to each other. So what that means is this function is an even function. It is even. Okay, let's try the g function over here. I have a g of x equals this rule. Now let's go ahead and find the g of the opposite of x. The opposite of x. Well, we're going to compare and see what happens. I'm going to plug in negative x for my x and negative x for my x here. And so what is negative x cubed? It's negative x cubed. And this becomes plus 4x. Now compare this to this. Are these functions opposites of each other? They are. So the g, when I plug in negative x to my g function, I get the opposite of the answer I got up here. So over here, let's look. I plugged in the opposite of x, and my answer was the opposite of the original function. So this g function is an odd function. It is an odd function because I plug in negative x, I get the opposite answer, okay? When I plug in negative x over here, I get the opposite answer of what I got for y originally here. And that's why it is odd, okay? You plug in the opposite x and you get the opposite y. Here, you plug in the opposite x and you get the same y. Okay, now let's look at our last h function, and we have x squared plus x. Now let's plug in the negative of x and see what happens. Well, negative x squared is x squared, and then I'm going to plug in a negative x over here, and I get x squared minus x. Now let's compare these two. Let's compare these two. Are they the same? No. Are they opposites? No, they're not. And so guess what this function is? It is neither even nor odd. It's not going to be symmetric across the y-axis, and it's not going to be symmetric about the origin. So that's how we find even, odd. And let me go ahead and put neither. Let's put the answer. Let's finish this up. And neither is my answer, okay? So I boxed these to compare them, but you would not box these in your answer. When you do this for homework, you're just going to put neither, odd, or even. Okay, so we've learned how to graph even and odd functions, and we've learned how to figure out which is even, odd, and neither algebraically. So that's our lesson for today, and I hope you do well with it. If you need help, I'll be here during Zoom time, and I have put these trig graphs on your, class resources section of LMS. Yes. So anyway, you can look there, and like I said, I apologize. There are two big graphs per front and back. I've got it where you can duplex it if your printer will do that, or if you want to just draw it real neatly, that's okay too. All right. Well, I hope you have a blessed day, and I'll be back with you on Monday unless I see you at Zoom time. Bye-bye.